Okay, so I wanted to do an example involving unit vectors. Remember, what is a unit vector? It is a vector that has a unit magnitude, meaning the length is 1. So in other words, we can put here length, and that's the same as the magnitude is equal to 1. So a unit vector is a vector whose length is 1. And if A is not equal to the 0 vector, then the unit vector with the same direction is, and then here's the formula. So this is going to be that unit vector. This is called the vector that you get when you normalize A. So the idea is if A is a vector, so say if A is some vector, maybe it's like that. Right, there's the tail. That's the tip. You want to take that vector and you want to have the same direction, but you just want to scale it so that the length is 1. So it's the same direction, but you just want to make it so that the length is 1. Well, what do? Well, this is your vector, and this is the scaling factor. And the reason why this works is because, remember, since u is a scalar multiple of this vector, then u and A will have the same direction. So they'll be parallel. Remember, two vectors are parallel if and only if one is a scalar multiple of the other. And then to verify that u is a unit vector, all we have to do is compute the magnitude. So let's compute the magnitude of u. The magnitude of u is going to be the magnitude of 1 over the magnitude of A times A. But we use our properties of vectors, properties of the absolute value or the length of a vector, to say that this is the absolute value of the scalar times the absolute value, times the length of the vector. So it'll be 1 over that, right? But this is just going to be 1 over the magnitude of our vector times the magnitude of our vector. Those cancel out and we just get 1. So the length of u is equal to 1, which means it's a unit vector. And u is going to be parallel to A because u is a scalar multiple of A. Okay, so let's do this example here, which is find the unit vector in the direction of the vector 2i minus j minus 2k. Okay, so we're going to use this formula here, right? So now our A, so we've got our vector A. A is going to be 2i minus j minus 2k. And I should really put a little arrow so that we know that we're talking about vectors here. Now this is the same thing as 2, negative 1, negative 2. Now how do we get that? Remember, that's going to be 2 times I, which is 1, 0, 0. And then minus j, which is 0, 1, 0. And then minus 2 times k, which is 0, 0, 1. Right? So now we scan that in, so we'll get 2, 0, 0, minus 0, 1, 0, minus 0, 0, 2. Okay? And so now I've got 2 minus 0 minus 0, so that'll be 2. 0 minus 1 minus 0, that'll be minus 1. And then 0 minus 0 minus 2 minus 2. Okay? So that's how we get A. And we're expressing it as in components. Okay? And so now I need that my unit vector is 1 over the magnitude of A times A. So in order to use this formula, I need to find the magnitude of A. So to find the magnitude of A, I'm going to use the formula that the magnitude of A is the square root of a1 squared plus a2 squared plus a3 squared. Okay? So here, a1 is going to be 2, a2 is going to be negative 1, and a3 is going to be negative 2. So I'm going to have 2 squared plus negative 1 squared plus negative 2 squared. And then I need to add those up and take the square root. So that'll be 4 plus 5 plus 4. That's 9. So we get the square root of 9, which is 3. Okay. So I can put that back in my formula here. So I'll have 1 over 3 times a. Now what is a? We've got a. A is 2, negative 1, negative 2. Right? 2, negative 1, negative 2. Oh.
It's 17:45.
Okay. So remember, in order to scale, I just need to multiply each of those components. So I'll have 1/3 times 2, comma 1/3 times negative 1, comma 1/3 times negative 2. Okay. So that means I'll have 2/3, negative 1/3, negative 2/3. So this is my final answer. So this vector has the same direction as A, and so U has the same direction as A, and U is a unit vector. Okay, so what we would say is that if we normalize A, we get U. Okay, that's a concrete way to say it.